Hi everyone, this is lesson 3.1.1, and in this lesson we're going to be looking at the exponent laws. And our first example asks us to simplify by applying the laws of exponents to the following expression.
Okay, so we're going to simplify this expression right here, the negative 4xy to the negative 5 z cubed over 1 half x to the negative 2 yz to the 4, and that's all going to be to the negative 3. Okay, so now let's zoom out just a little bit here. So now what we're going to do here is take a look at order of operations specifically. We're going to take a look at what's going on in the inside here. Now, to start off with, I think it makes sense to do the coefficient here. We're going to go negative 4 divided by a half. Okay, when we divide by a fraction, we multiply by the reciprocal. And so negative 4 is going to be times 1 half, and the reciprocal of 1 half, I should say, will be negative 4 times 2, or negative 8. So we're going to keep these brackets right here, but that's going to end up becoming negative 8. And now I'm going to group together the factors here that have the same base. So in the numerator, I've got an x to the 1 divided by x to the negative 2. So I'm going to write that as x to the 1 minus, because of the division, negative 2. Now I've got to remember to keep the signs in there correctly. Then I've got y, power of y to the negative 5, divided by y to the 1. So this will become y to the negative 5 minus 1. And then I'm going to have z cubed over z to the 4. So that will be z to the 3 minus 4. Okay? And this will all be to the negative 3. Now, but I'll deal with that later. Okay, because order of operations tells me to focus on what's inside the brackets first. Okay, so now, kind of simplifying this simplifying this out here, we've still got the negative 8 there. Can't do anything with that. Now, 1 minus negative 2 is going to give me x cubed. Then I'm going to have negative 5 minus 1 will be negative 6. Okay, 3 minus 4 will be z to the negative 1. And this will all be to the negative 3. Now our next step is going to be to distribute this negative 3 to each factor in the set of brackets here. Now I can do that because there's no addition or subtraction here. Granted, there's a negative sign out front, but that's part of this coefficient. So there's no addition or subtraction, so because it's all, in essence, multiplication or division, I can distribute that exponent to every factor here. Okay, and so this is going to become negative 8 cubed, x cubed cubed, y to the negative 6. I'm sorry, and I keep doing this. It should be the negative 3, negative 3, negative 3. And then z here to the negative 1 to the negative 3. My mistake. I should have kept that negative with it the whole time. Now, here we go. What the negative does, okay, the negative causes a reciprocal of the negative 8. That negative will not influence the negative out front. Okay, these are two different negatives. This one here in the exponent merely causes a reciprocal. Now, the cube on the negative is going to keep it negative, so that's not going to do anything here. But 8 cubed, then that 8 drops to the denominator. This will become 8 cubed, and that is going to be 512. We'll just do that right away here. Then we're going to get, when you have two powers multiplied together, we probably want to deal with this first here. So when I have power of a power, I multiply the exponents. This will be x to the negative 9. I'll deal with that in a bit. Here, same thing, power of a power. So I'm going to multiply the exponents, and I'm going to get negative 6 times negative 3 will be positive 18. And then over here, negative 1 times negative 3, okay, because the power of a power again, will give me positive 3 here. Now, between all of these factors here, the y and the z are going to stay in the numerator, but the x to the negative 9, that negative is going to cause it to reciprocate here. So this will end up becoming negative y to the 18 z cubed all over 512 x to the 9. Okay, and the reason we start with a question like this is really just to get you thinking about exponents again, the laws of exponents, okay? Because logarithms are related to exponents, and so you're going to see these laws carry through into our work on logarithms.
For question 2, we're going to want you to solve the following exponential equations.
Equations here. So I'm going to start with this one. 5 to the 4x is equal to 125 to the x minus 1. Now, one way to approach this, and I think it's a good way to start these things, is to just check the bases here and the powers that you're seeing, and are they related? And in this case, yeah, they are. 125, just like 5, this is a power of 5. Okay? And so one of the first things we want to do is we want to rewrite these things as powers of the same base here. So 5 to the 4x is going to equal, well, this 125 will be 5 cubed to the x minus 1. Now, if you don't know that off the top of your head, that's okay. Just play with your calculator a little bit, but you'll find that 125 is going to be 5 cubed. Now, to solve this, the next thing that we want to do here is, essentially what we want to do here is we want to get the exponents. We want to get it so that's power equal to power, okay? Because if you've got power equal to power, if you've got base to some a here and base to some c here, if you've got it set up like this, okay, power equals power, if the bases are the same, well then it has to be true that the exponents are the same. Has to be. If this is equal to this and the bases are the same, then the exponents must be the same. So that's what we're going to take advantage of here. But what we want to do is we want to clean up the exponents a little bit. On the left-hand side, there's not much to do, okay, because 4x is nice and the base is correct here. But over on the right-hand side, I've got a power of a power, and so I got to multiply the exponents together. Now, here's a really common spot for an error to pop up. And you got to be really careful about this. This is 3 times x minus 1. The really common error is to write it as 3x and not even, sorry, and then I didn't make the error. Sorry. The really common error is to write this out as just 3x minus 1 without distributing the x to the 3 to the binomial. But to get this correct here, that x minus 1 as a binomial is the outside power here. The whole thing gets multiplied by 3, so I have to distribute the 3 across, and there we go. And now I've got power equal to power. The bases are the same, so the exponents must be the same. Okay, it's not that I'm canceling the bases. There's no operation that does that. But I'm just saying that if they're equal and the bases are equal, I can conclude the exponents must be equal. And now I just solve this. I will subtract the 3x from both sides. And so x is going to equal negative 3. And that's the solution that I was looking for.
The following equation is going to require the application of one of the exponent laws to solve it.
We've got to solve this equation here, and again, just like the previous question, what we want to do here is take a quick look at the bases. Okay. Now notice that 3 and 3, I mean, they're the same base. And then I've got this 27 to the 3x. Now 27 is also a power of 3, and that's the whole point. I want to be able to recognize that. But before, and I'm going to do that, so on the right-hand side, I'm going to rewrite the 27 as 3 cubed, and that is the base, and that would all be to the 3x. Okay. But I need to recognize over here what else is going on. Now the reason why I chose this particular question here is because it's a really easy mistake to make to forget about this 3 right here. Okay? Sometimes people don't forget about it and they'll make this 3 to the 5x times 3 makes 9 to the 5x, but that's not true. I cannot multiply before I do or deal with the exponents here. Okay, so I have to deal with the exponents first here. In order to multiply these powers together, the base is the same. I just have to recognize that if the exponent isn't written, it's 1. And so when you multiply these together, you get 3 to the 5x plus 1. Okay, I don't multiply those bases together to get 9. Okay, that would be an inappropriate way to multiply those together. The way to multiply them is to add the exponents. Now, on the right-hand side, I'm going to simplify that, okay? This is 3x times 3 because it's a power of a power, so you multiply it, and there's a 9x. And once I've got power equal to power, where the bases are the same, I know that I can write this as 5x plus 1 is equal to 9x. And maybe I will bring the 5x term over, so 1 is equal to 4x, and then divide by 4, and I will get that 1 over 4 is equal to x, or x is equal to a quarter. And that's what I was looking for.
This next question is going to require the application of a different exponent law to solve it.
We're just going to solve this equation here by, again, looking at the bases here and seeing what's common amongst the bases. Now notice this is 1/4 to the x equals 8 to the x over 4 to the 2x minus 1 here. Now look at the bases. 1/4, 8, and 4. These are all powers of 2. And so to find that commonality here, I'm going to reduce every one of those bases to its power of 2. 1/4, well, okay, notice that's 4 in the denominator. Now remember how this works. If I want to get something, if I want to flip that thing out of the denominator here, I'm going to pull it up to a negative exponent. So this is going to become 4 to the negative 1 to the x, because I'm just playing with the base here. 8 is going to be 2 cubed to the x. And then the 4 in the denominator, that's going to be 2 squared, whoops, no, that's right, 2 squared to the 2x minus 1. Now, I'm going to work with this 4 to the negative 1 to the x. This is going to become 2 squared to the negative 1 to the x. And now I'm just going to simplify the numerator and denominator here. The bar here, the division, okay, we know that the bar means division, but it also implies a set of brackets around the numerator and denominator. So I really should simplify what's going on up here and down here before I put them together. Now, the more comfortable you are with this, the faster you can move through it. But if you're not super comfortable with it, I really advise you to just take your time. So power of a power, I multiply those together. So this is 2 to the 3x over 2 to the, now this is a power of a power. Okay, I've got a binomial times a monomial here. I need to remember to distribute the monomial through. So this will be 2 to the 4x minus 2. Over on the right-hand, sorry, the left-hand side, I should say, left-hand side, this is going to be 2 to the 2 to the negative 1 to the x. Now this is a power of a power of a power. I am just multiplying all those exponents together. So that's going to give me 2 to the negative 2, negative 2x will equal. Now on the right-hand side here, I'm dividing. There's no more simplifying that I can do. Just slide this up a little bit. So when I divide, I need to subtract. Now this is going to be 3x minus, and I'm going to put brackets here because I don't want to make a mistake here. I'm subtracting this entire exponent, not just the 4x, the entire thing. So in brackets here, 4x minus 2. Okay, so on the left-hand side, there's nothing more to simplify. On the right-hand side, this becomes 2 to the 3x minus 4x plus 2 when you distribute the negative through. So that's 2 to the negative 2x, okay, is going to equal 2 to the, well, 3x minus 4x is negative x plus 2. There's no more simplifying that I can do, not in the exponent here, okay, and I've converted everything to the same base here. So power is equal to power. The bases are the same. That's exactly what I was shooting for here. So I know that the exponents must therefore be the same in order to maintain equality. And so now, I don't know, maybe I may move this negative x over by adding it to both sides, and I'll get negative x is equal to 2, and then divide through by the negative, and I'll get x is equal to negative 2. And that's the solution we were looking for.
This final exponential equation is going to require the use of the reciprocal law in order to solve it.
We're just going to solve this exponential equation, but we're going to do it by focusing our attention on the bases here and looking for a connection. And you should always be doing this regardless of, at least this would be the first thing you do when you're looking at an exponential equation. Now notice the connection here between 64, okay, 64 is 4 cubed, 125 and 5, well, 125 is 5 cubed. But notice that they're reciprocals of each other, the bases here. Now I'm going to have to deal with that in a bit. Well, the first thing I'm going to deal with is the value. Okay, now there's really not much to do over on this left-hand side, so this will be 4/5 to the 5x. But I am going to try to deal with this 125 over 64. That's a base, that's a power with a base of 5. The 64 is a power with a base of 4. And those are cubed, all to the negative 3x plus 1. There's that outside exponent. Now, these are almost identical, except that one is the reciprocal of the other. So I got to flip something here. Now, it doesn't really matter which one I flip, but I like kind of having the smaller number up top here. So I'm going to leave this side the way it is. But we're going to reciprocate this to make it 4/5 here. That's going to put a negative in the exponent because of the reciprocal, and there's already a 3 there, so that'll make this -3. This is still to the -3x plus 1. Okay, now I've got power equal power, I've got base equal base. I'm almost ready to equate the exponents here, but I should simplify this a little bit. So this is going to be 4/5 to the 5x is equal to 4/5 to the, well, let's distribute that negative through. So -3 times -3, x will be 9x minus 3. Okay, good. Now we've got power equal to power, base equals base, and the exponents are as simplified as they're going to get here. So now I can simply make the statement here that 5x is equal to 9x minus 3. Maybe bring the 9x over. I know a lot of people like to have the x on the left-hand side, so it'll be -4x is equal to -3. And so finally, I will divide both sides by -4. The negatives cancel, and I'm left with 3/4.
This next question requires us to solve the following equations that contain rational exponents.
But there's an issue here, and I'm going to zoom in on this now that you've seen the question. We're going to zoom in on this one. X to the 1/4 is equal to 3. Now, this is not an exponential equation. It's in this section here because we need to talk about how you approach questions like this, but this is not exponential because the independent variable is in the base of the power, not the exponent. Okay? We label equations by where the independent variable is located. If it's in the exponent, it's exponential. If it's under the radical sign, it's a radical equation. Okay? If it's in the denominator, it's rational. So how do we deal with this? Well, what we want to do here is we want to get rid of the exponent on the x. And so what we're going to do is we're going to take both sides of this equation and we're going to raise it to the reciprocal power, okay? We're going to use the reciprocal power. Or actually, I should probably say the reciprocal exponent. That's better vocabulary here. Reciprocal exponent. Oops, can't see that. Okay, now the reason for that is because when I put this to the reciprocal exponent, to the 4/1, bear in mind that I'm now creating a power of powers. So what I'm going to do is multiply these exponents together. So this will be x to the 1/4, that's what's there, multiplied by 4/1, and this will equal 3 to the 4/1. On the left-hand side, 1/4 and 4, when you multiply them together, they just become 1. So we're left with x. And now when I evaluate 3 to the 4, I get 81. And so that's how you deal with these kind of equations. If the variable is in the base, I don't need to be solving this the same way that we did the questions from the previous question that we were just doing.
And now we're going to look at a similar equation, but this one will have a negative in the exponent.
Again, just to reiterate, this is not an exponential equation because the variable is in the base. So it requires a different approach. And what we saw with that last question is that what we're going to do here is take both sides to the reciprocal exponent. Now, the reason why this question is here is to highlight where a mistake could pop up. When we say reciprocal exponent, I simply mean that we're taking the the numerator and the denominator and flipping them. The sign does not change here. So I'm going to take this to the -3/4. Okay, so then this is now a power of these powers here, so this will be x to the -4/3 to the -3/4. This will be equaling to 625 to the -3/4. Okay, here these values here, they cancel and the negatives cancel importantly. That's why I wanted to keep the sign there so that the negatives would become a positive, and this simply becomes x to the 1. Now, this is an interesting little scenario here. The negative causes a reciprocal, so let's deal with that. This is 1 over something. So once we get rid of that negative here, now we've got to the 3/4. Well, 3 will be the power, 4 is going to be the root index, so this is going to be the 4th root of 625, and then this will all be raised to the 3. Now, I prefer to do it this way. I know that you can cube on the inside, but I prefer to get smaller numbers first and then make them larger because of the power here. The 4th root of 625 is just going to be 5. And when I cube that, I get 125. So this is still in the denominator, so it's going to be 1 over 125.